Okay, I think we could start. Hello, everyone. It's very pleasure for me to see all of you here, and glad to welcome you to this webinar. And first of all, I would like to check if we have a good connection. Can you hear me? Please type plus in the chat box if the signal is good. Okay. Okay, fine. So today our topic, the topic of our webinar is the use of dynamic production profiling data in petroleum data analytics. And speaker today is Nadir Husein. He's our employee, and Nadir has 20 plus years of extensive administrative, technical and operational experience in the integrated application of hydraulic fracturing. And also he has experience in regional sales, and also he held various positions in major international oil field companies in North Africa and the Middle East, and graduated of American University in Cairo with degree of mechanical engineering. And he also has several courses in sales in the UK, in USA, in UAE, France, and other countries. And also he's a member of SPE and Energy Me Ambassador. So he's gonna make a presentation today. So Nadir, please take your turn, please. I can start presentation. And
thank you.
For all participants, if you have any questions during the presentation or after the presentation, please type it in the Q&A box. Once we finish the presentation, all the questions will be answered. Thank you.
Thank you, Igor, for the introduction. Good morning, good afternoon, good evening, ladies and gentlemen. On behalf of the Geosplit team, I would like to thank you and welcome you to this webinar, which carries the title, The Use of Dynamic Production Profiling Data in Petroleum Data Analytics. So before I start the presentation, just a quick introduction of Geosplit company. The company is of Russian origin. Basically, the company has a product portfolio in the domain of inflow tracers. And the idea was born back in 2013, where the founder wanted to incorporate chemical tracers into coated proppant. And ever since then, we developed quite an interesting portfolio where we use nanomaterials, quantum dots, as tracers primarily in the domain of production profiling. Today, we are present in Russia, China, Middle East, serving already more than 230 wells in throughout the world. Most recently, we start focusing on how do we now implement the data that we get from production profiling, which we call dynamic data or big data, in a data-driven models that could help the end user to do predictive analytics to optimize and automate the decision-making in ultimate quest to improve the hydrocarbon recovery. That will be also the main topic of today's presentation. So Geosplit today is positioned to be an international digital oilfield service company. And as I mentioned, with a big focus in provision of tracer-based production surveillance and digital solutions. So this is the agenda. The first part of presentation, I'll just spend explaining the Geosplit product portfolio, the quantum dot inflow tracer technology, how we use it in different applications, primarily in single wells and then multi-wells. And then I will spend the second half of presentation explaining how we start using this data in integrated workflow in the quest to improve the field and reservoir management, ultimately doing a better hydrocarbon recovery. I will touch base on what we are focusing beginning of this year and onwards which is a data-driven models and machine learning, where we are trying to give the end users now an ability to automate and better design the field development. I will also spend at the end of a couple of slides on explaining a Geosplit unified digital platform, which is a proprietary software that we developed and which is basically a central dashboard that we internally use and also the end user can use in analyzing different field development strategies. So I'll start with explaining the INFLOW tracer technology workflow. So as I mentioned, what we use as a basis is the quantum dots, and those are nano-size solids or crystals, typically between 2 and 10 nanometers in size. They are chemically, biologically, and physically stable, so when they are exposed to harsh reservoir environment, they preserve their properties. And the key feature that we use in quantum dots is the fact that when they are exposed to a certain electromagnetic wave or a laser light, they emit a very distinct electromagnetic spectrum or an array of colors, which we can see with the naked eye when you have a highly concentrated quantum dot samples. So this allows us to create a substantial number of unique signatures. Today, we commercially offer 63 different signatures for each fluid phase for oil, water, and gas. So what we do is we encapsulate those quantum dots or combination of quantum dots with polymeric spheres. And those polymeric spheres are typically in 300 nanometers in size. And those are the ones that we deploy in the reservoir or the wellbore. And those are the ones that are controllably released in the reservoir fluid and later on captured on surface for the analysis. Now, we use different conveyance methods. As I mentioned, we started off with the coated proppant, where we coat the proppant or sand grains, and typically we place them in each of the frac stage with the unique codes, and then later on we are able to do production profiling of each of those frac stages. Just as a rule of thumb, we use approximately 10% of the total frac volume with the coated proppant. We also place those tracers in downhole completions, typically in horizontal open hole completions with swellable packers, such as ICV or multi-stage frac completions. And we use actually a very elastic composite material, mark tape, which contains the tracers. And typically this is placed on a blank pipe of the completion. And then once the well is put on production, the flow touches the composite material, releases the traces and carries it to the surface, where we capture it and analyze it. The analytics methods that we use in the lab environment is flow cytometry, which I will go into details in subsequent slides. But what we provide to the client is quantitative analysis of zonal production contribution of each frac stage or horizontal well compartment. And we can also provide quantitative analysis of all three phases, oil, water, and gas. Obviously, such data now gives the end user more data points on the next level of production surveillance, not only on the well level, but now on the different zones of the reservoir inside each well. So just quickly explaining the analytical method that we use. As I mentioned, it's flow cytometry. We adopted that from biotech and medicine, where this method is used to analyze different human cells, like blood cells, and in a quest to diagnose diseases, etc. So we use the same concept. The key part of the flow cytometry is the capillary tube on this picture, which has various sizes. What we use Geosplit is a capillary tube up to 2 microns. And the key concept here is that when you introduce a sample, any particles that are less than 2 microns will be passing through the tube one by one. And then when they are exposed to different laser channels, we capture that response with in-house built software, which has machine learning capabilities just to ensure the accuracy and efficiency of the analysis. And we basically quickly sort different tracers or markers present in the sample, and this allows us to basically produce quantitative analysis of production flow. Just for the clarity, as I mentioned, we have 63 different codes. So you know, the combination of different quantum dots within polymeric spheres can give us unique signatures. So for example, here, if we have a combination of fluorescent and green quantum dots, that could be code 1. And then, for example, if we have a combination of blue and red quantum dots, that could be code 2, etc. This is just an electronic scanning image of polymeric spheres that contain quantum dots in composite material. So how does the release mechanism work? As I mentioned, we place the polymeric spheres in a composite material, which is in homogeneous microfield material, and it is pre-designed depending on which fluid phase we would like to trace. So we have a material for oil and then material for water and also for gas. So what happens is that once the flow gets into contact with the material, it slightly swells, and then those diffusion channels are created. And then when there is enough kinetic energy or flow velocity, the composite, or sorry, polymeric spheres are released in the flow and then carried to surface. There is actually a direct relationship or linear relationship between the number of those polymeric spheres with the flow velocity. And this is the key concept that allows this technology to produce quantitative analysis of all 3 phases in the flow. So, as I mentioned, the simple data that we give to the client is actually a zonal contribution of each compartment in the well, whether it's a frac stage or ICD compartment. And we basically can analyze a zonal contribution of all 3 phases. This graph shows, for example, only 2 phases, oil and water, and we basically reproduce the percent contribution of each phase within each zone to a total flow rate of a given well. Obviously, we provide this well performance over time, and definitely now it gives better insights to the client to optimize the well performance, do decision making if the completion strategy needs to be changed in the further wells to be drilled. It can also help in the scope of hydraulic fracturing to optimize the frac spacing, frac design, etc. In essence, it gives the next level of production data to the client or end user to be able to do a better future decisions for field development. When it comes to multi-well environment, obviously placing inflow traces in different wells in the cluster of the field can allow now looking into the interaction between those wells, which then can improve methods like infill drilling, like enhanced oil recovery, which I will go into it in more details. And eventually it can help the client optimize the field appraisal and the field development. Now, the key advantages of this technology to the client is the fact that when you place quantum dots, you don't need to shut off the wells to be able to do the production profiling. So you're avoiding production deferrals, or you're avoiding any unnecessary closure of the wells. This method is interventionalist, so compared to any other conventional production profiling methods like cold tubing or wireline conveyed PLT measurements, it is interventionalist, so it substantially reduces the HSE and operational risks, and definitely it also reduces the cost. And what we've seen in the last couple of years, this is the key factor now for the end user to do production profiling much more frequently than in the past, which means that if the clients used to do 1 PLT per year in each well, now they're doing a more frequent, let's say monthly production profiling, which now gives the client much more production data. As I mentioned initially, it gives the insights for better decision making in optimizing the production, etc. But now with this big data, client is able to use it and use it in data-driven models, for example, to be able to improve reservoir models, hydrodynamic models, or use such data-driven models in automated or better predictive analytics and do more accurate decision making in the future. So just a quick number crunching, just to show the cost advantage. This is a case back in Russia with the client that had a certain AFE budgets for drilling the horizontal wells over a 4-year period, and the initial strategy called to drill 500-meter horizontal sections in each of those wells. Early in the field development, the client adopted the use of inflow tracers back in 2017, and ultimately within 4 years, just by using the inflow profiling now, the client start reducing the horizontal section with maintaining the production and basically reducing the capex cost in the field, which totaled to 3.5 million in this case, which was a substantial cost reduction. Now, this slide just quickly shows the case study where you use the inflow profiling in single wells. So this well is a horizontal well that has a multi-stage hydraulically fractured horizontal section with 9 different stages. If I draw your attention to this picture, so basically it shows that it passes through a very layered reservoir section. So there is a quite heterogeneity in the reservoir quality. So when the client start putting well on production, we could quickly see that the middle section of the well is not contributing to production. And immediately this is an insight for the client to use this data in subsequent future wells that are also horizontally drilled and fractured. So the client decided to change the frac spacing, avoiding the low porosity and permeability zones, and i.e. Saving the operating costs during the fracturing operations. This is a multi-well case study, also back in Russia, where a client was developing a field where they were drilling the wells to be immediately fractured. So wells were fractured with the 5 different stages. And what client, they start measuring the production basically now on a regular monthly basis, and they start getting a quite unique profiles, which you would be J-shaped, which means that the production was predominantly coming from the heel, then L-shaped, where the production was predominantly coming from the toe, and U-shaped, where the fraction was coming, or production was coming from the heel and the toe. Obviously, in the strategies like projects where you have enhanced oil recovery, the clients start using this data to relate the efficiency of surrounding injectors. So the first hypothesis that they got just observing the production profile is that the surrounding injectors are supporting only heel and the toe in a U profile, or the heel only in a J profile. This further triggered the concept of using now the production profiling from the inflow tracers to optimize the water flooding projects. So the client had a more systematic approach where they basically had a workflow where they were looking at existing reservoir geological structure. They also looked at the existing historical production and injection profiles, looking at the water cut patterns, trying to understand the efficiency of water flooding, etc. Now, what Geosplit jointly did with the client is start using the data-driven models in steps 4 and 5, and I'll go into detail of it. But basically, we start using now the data that we are getting from production profiling of different fracturing stages in each well into data-driven models where they were using probabilistic models like a Spearman rank order correlation method or capacitance resistance method. And those models were not a replacement of existing simulators, but rather they were complementary to the existing simulators. But definitely such data-driven models are much more faster and efficient in data crunching, which enable the end user to generate different scenarios, for example, just changing the injection profiles, and enable the end user to make quick decisions to optimize the injection profiles. The end objective of such workflow is to, after we use the data-driven models, to basically deduce the sets of actions that would ultimately either improve the current production or improve the hydrocarbon recovery on the well level, not only on the cluster level of the field. So this slide quickly just shows how one of the data-driven model was used. This is a Spearman rank order correlation method. Basically, this method uses injection profiles and production profiles between the injectors and producers in certain cluster of the field. So in this case, the data-driven method was applied in those two areas. But now the input was not just only taken on the single well level, but inputs were taken on each fracturing stage in each producer. Just to benchmark the results, this method was compared with the existing hydrodynamic reservoir model, and it was concluded that areas 1 and 2 in both methods were the ones that give the best reservoir drainage. Now, once those data-driven models were implemented, the end user was able to create a set of actions which were ranging like switching the producers to injectors in the areas where there is extremely low production of oil and high water cut, and that would definitely improve the efficiency of the waterfronts. They also look at the reservoir or pressure management within the reservoir. So in the areas where the reservoirs were low, it was decided to do the stimulation interventions just to remove the filter cake and reduce the skin. And in some other wells where the production was quite higher than the other parts of the field, it was decided to choke back the production to maintain the drawn down eventually and the reservoir pressure. Further on, certain thief zones were identified between injectors and producers. So the decision was made to use the polymer systems to plug those thief zones. Another decision was to basically do the infill drilling just to intensify the development of remaining oil in place. And all those basically allowed the end user to increase the flow rate, average flow rate per day, to 1.9 tons per day, which would eventually give the client an incremental production increase of 1,900 tons over 8 months. And what was more important to the client in this case study was to reduce the water cut. In some areas, the water cut reached even 70% on individual wells. And with this model, client was targeting to reduce the water cut by at least 20%. So now going a little bit more detailed in the data-driven models that were used. One of them is capacitance resistance module, which is not new in the petroleum data-driven analytics, but what's specific in this case is that, as I mentioned, now the production profile is not only looked at each producer level, individual well, but rather looked at every single hydraulic fracturing stage in the case history that was explained. So basically, as I mentioned, such models don't carry a better accuracy compared to the existing physical models, but they are much more faster and efficient to create different scenarios for better decision making. Obviously, one of the validation method is to look at reservoir simulator and look at the production history matching between the two models. Couple of disclaimers to make is that such model accuracy is increasing when there is a lot of historical data, and we are looking primarily on injection profiles, production profiles of each producer on a frac stage level, and we are also looking at the injection pressure. So the more data we have, the more accurate model becomes, which then allows us a better prediction for the future models. Since this is fairly new implementation, the case studies that we did, which are few, were carrying only two years of production history. This is just another module that we looked at, which shows the coefficient of interference between injectors and producers when we look at the water cut and the fluid flow rate. If you look at the map, just looking at the two producers, in this case, the blue circle and the red circle, well, number 1 and 2, and their interference with surrounding injectors, we're primarily looking at the injector well number 3 and injector well number 4. And with obviously established now coefficients of interference, you can quickly make decisions like, you know, is the water injection potentially inefficient from injector well number 3 to producer well number 1, just looking at the correlation of interference coefficients for specifically water cut and fluid flow rate. What we would ideally want to have is a typical piston flow where the waterfront is pushing the oil towards the producers in almost 100% efficiency method. And what we were trying to avoid is obviously the water breakthrough. Again, such modules are just complementary to the existing reservoir hydrodynamic models or physical models, but yet they can give the client a quick tool to look at different scenarios in the future and try to optimize primarily the injection profiles and ultimately improve the hydrocarbon recovery now, not only on the well level, but even on the fracturing stage level within each well. So just at the end, as I mentioned, Geosplit most recently developed a unified digital platform, and the whole idea is to have a one-stop shop of all the data, input data needed for every single well, field and reservoir. And then with the combination of existing probabilistic or data-driven models and Geosplit algorithms that we are developing, ultimately we would like to give end user the tool that would allow an automated system for all field development and real-time control. So just quickly, this joint data center obviously has data from production profiles generated by using Geosplit inflow traces. Obviously, also we gather the data from the end user when it comes to geological model, the petrophysical models, etc. And then we have a centralized system that uses all this data and machine learning algorithms to be able to visually provide the insights to the client and ultimately better decision making. We have two trademark modules, GeoExpert and GeoOpt. GeoOpt is still in development phase, where we want to provide the plugins to the current commercial reservoir simulators like T-Navigator or Eclipse, so that the data that is obtained from inflow profiling using Geosplit marker reporters can be fed into those models. And GeoExpert is basically what we are focusing on now to develop in-house data-driven models that can be used for predictive analytics and better decision-making for the end user. This is the last slide, just showing the typical inputs from the dashboards from Unified Digital Platform. What we are trying to give to the end user is business intelligent and analytics visuals that can allow the end user to better understand the data and make decisions. Obviously, the input is now automated. It is centralized. The data is centralized in one center. And obviously, we also have a hierarchical storage of documents on stage level, well level, field level, reservoir level, obviously the client level, etc. And such architecture also allows a better data processing, analytics, and visualization. So with this, I end today's webinar and open the floor for your questions. So I'll just go over the questions in the box. So it seems that there are no questions
Nadir, here is Andres Blanco raised the hand. Yeah, so he typed. Okay.
So the question comes from Andres Blanco, and he's saying that if we can you bullhead the traces. So there is one of the conveyance methods that we use with the solid traces, and typically it's used in matrix acidizing applications, or even within the fluid systems of fracturing applications, whether it's acid frac or slick water or cross-link fluids. So we can place our traces in those fluids, and then you use those traces typically to evaluate the efficiency of the production enhancement treatments, as I mentioned, either matrix acidizing or fracturing. But definitely we can use it in bullheading applications. So there is another question from, I guess, Lester Ayfield, if I'm pronouncing it correct. So the question is this designed for horizontal wells only? So typically, most of the application fall for horizontal wells, but you can also use such traces in vertical wells. One example would be if there are multi-zones within one reservoir and within a vertical well. The only thing is that we need to ensure that those traces are placed in each of those zones or physically isolated when we do the placement. So some sort of physical isolation is needed, or if, again, I'll go back to the mentioned application of matrix acidizing, if you use certain diversion techniques, whether they are physical or chemical diversion, it could enable us to place different unique signatures in different zones within the vertical well. Another one. So there's a question about the sampling. For the sampling, again, this is from Andres Blanco. For the sampling, do you need a permanent reading on site or collect the samples and then send them to the lab? Today, we do collect samples on the well side and then analyze them in the lab. So we still don't have any real-time analytical method to be able to do the analysis in a real-time mode. One thing to mention, the flow cytometry, the analytical method that we use is quite portable, and it is possible to deploy the portable lab on the well site. Another question, again from Andres Blanco, do you have experience in sandstones? Definitely we do. The conveyance methods that we use in sandstones are obviously hydraulic fracturing, but again, we see more and more traction or adoption of using such traces in downhole completions. And then in that case, you are placing the traces in the wellbore rather than the reservoir. And definitely, we do have case histories where we place those traces in the sandstones. And Andres, we can share it separately. There were a couple of SP papers written on that. So I can contact you after the webinar and share the experience. Another question from Lester. Have you all conducted any case studies in offshore wells? Yes, we have case studies in Russia, if I'm not mistaken, in Caspian Sea as well. And we will be deploying the traces in downhole completions for the client in UAE, and that would be also in the offshore environment. Another question from Andres, have you used the portable equipment during the well kickoff? Unfortunately, as of today, we didn't use portable equipment yet. But again, operationally and technically, it's possible. So if there are applications, we can take the discussion in a separate meeting. Yeah. Another question again from Andres. In sandstones, basically what Andres meant was if we used our traces in water injectors in sandstone reservoirs, so the traces can be used. On top of my head, I don't know whether we did it or not, but we will get back to you, Andres. What is the most important thing when we talk about the use of those traces in injector is the permeability. So for very tight reservoirs, and that's why I'm not now talking about whether they are carburet or sandstones, and we are talking about up to 1 millidarcy, those our traces might block the pores. So typically we use it in the permeabilities that are higher than 1 millidarcy. There's another question from Wilson Lee. What is the success rate for tracing gas phase using inflow polymer in lower completions? Today we have 2 case histories in offshore environment where we're using gas traces in lower completions, but it is in a 3-phase production flow, and the implementation is successful. Apart from that, we also used gas traces in coated proppant in China in coal bed methane reservoirs, but that was only placement of gas traces in a dry gas reservoirs, and that was also a successful deployment as well. We've been monitoring the wells now for almost 2 years. For the rest of the audience, if you want to ask the questions by voice, please raise hand as well. Another question from Lester: can this be used in drilling fluids as well? At the moment, the traces are used only for inflow or interwell production profiling, but this is not the first time we get this question. There are potential applications in drilling fluids closely related to mud logging, where you can tag the drilling fluids and get a maybe more accurate position of different rocks within the reservoir. But at the moment, it's not commercial yet. Another question from Andres: how is the sampling or sample storage and analysis of gas traces? So for the gas traces, we use a different sampling method. We have a portable device called gas catcher, or alternatively, if the client can do or provide the bypass line, what we do is we place the pre-designed filter membranes of a certain mesh size, and we capture the gas traces in those membranes, which is very reliable methods actually. And then what we do is at the end of sampling period, we remove the membranes, package them and transport them to the lab. And in the lab, with the very simple ultrasound bath, we transfer the gas traces from the membrane to distilled water, which is then ready for a flow cytometry analysis. Another question from Scott. Typical, how many samples are taken at the well site to be able to apply one production type log? So obviously it varies from well to well, but just to give you a flavor, we take an hourly sample, and typically we take 8 samples a day to be able to do the production profiling. And this is for two-phase oil and water flow. For the gas sampling, we do a quite different approach where we need to create impulses. But again, sampling is in 1 hour periods, and it takes no more than 8 hours. And I don't see any other questions. Maybe someone from the audience to connect with audio. Well, if there are no more questions, I guess we can conclude the webinar. Once again, thank you for your participation and attention. If you want any further follow-up, you can contact us on our website or directly contact myself and my colleagues if you have any other further interest to our technology. Thanks once again, and I wish you a pleasant end of the day. Thank you.